things, you're going to need this, this link and this Google Sheets. If you're having trouble on the Google Sheets, you have two options. You can quit Google Classroom. So if you quit Google Classroom from running in the background, it will hopefully allow you to edit in Safari rather than try to open it in Classroom. If you want to have a different workaround, you can also go to Graphical Analysis. So when you open Graphical Analysis, it looks like this, and you do manual entry. So then your data sets can go here, like your mass or your distance can go here, and then your force of gravity would go in your y-axis. So know that you also have that option. So what I'm going to do is I am going to have this animation open, and I'm going to take that adding a graph sample, and I'm just going to drag it over to the side of my screen so I can have a split screen view. And then on your animation, know that you can drag around where the ruler is, you can drag around where the objects are. You have sliders down here to change the masses of things. So a couple of things to notice is this is quantitative data. So before we've been doing qualitative, we've just been like faster, it moves, it doesn't move. But we are going to look at this qualitative data. And so another thing you might notice is this number is really small. We don't think of the force of gravity as being small when we have to carry a heavy load or going upstairs or if we fall down. Gravity feels pretty big then, but it's actually a really small force. To help us with that, down here we have this scientific notation. So if we click that button, for whatever reason it wants me to use my finger, when we click that button, then it'll make this number much more manageable and easy for us to put into our spreadsheet. But one thing to notice is that as I do my experiments, if I have really large masses, notice how I can't get my objects very far together. So if I click this constant size button, what that does is make, no matter what I set these masses to, they'll always be that same radius, so I can get them much closer together. So if you're doing a distance experiment, this is something to keep in mind. You might want to have that set to constant size. The other thing, the other limitation is you can't get farther than 10 meters apart. So just know that if you're doing a distance experiment, you want to make sure that to get all your data points in, you have to have 10 data points, that you keep that in mind, that 10 is kind of your limit there. So what we're going to do first is figure out, what did your instructor ask you to do? Or let you choose to do? Are you doing a distance experiment, or are you doing a mass experiment? Once you have that figured out, you need to set these controls down here, because if you don't get done in one setting, it will take your app and it might do that to you. It might change it back to its refreshed state. And so if you don't have these controls written down, you kind of have to start over. So we're going to keep constant anything that we're not testing, right? So if I'm testing distance, I'm going to keep my two masses the same. And so over here, I might put in the mass of object 1 might be 100. I'm going to set, and I want to set these to something random. So I'm going to set that to 370 kilograms. And you would pick something different than me, because then that would allow us to see if our data is reliable. And then I'm going to set this one to something different, 700, oops. I'm going to set this one to 720 kilograms. And so now I'm all set up to take a distance experiment. So then what that means is I can start to set up my experiment to take data. Don't change that. I'm going to put that on scientific notation. And I'm going to start my first distance, excuse me, at 2 meters. Pardon me, my asthma is not my friend. And so I'm going to set that to 2. Notice I took out the meter because that'll confuse the computer. And now what I'm going to do is I'm going to put this number into the spreadsheet. Notice they're the same. This is a balance system. They're not in motion. So those two gravitational forces are the same. So now I'm going to put 4.45. And then instead of this times 10 to the negative 6, I'm going to put an E and then the negative 6. And so that'll tell the computer what my data is supposed to be, and you'll notice that popped right in there to my spreadsheet. So if I did it again, I'm going to go ahead and move my object now. And so now I'm at 2.6 meters. And my force of gravity is 2.63 to the letter E, -6. And so now I'm starting to get my data points put into my graph. And it'll start to spit out a graph. So that's how I would do a distance experiment. On the other hand, if I'm doing a mass experiment, what I would do is I'm going to keep the mass of one of my objects the same. So it's 3. I'm going to keep the mass of, say, object 1 the same. It's going to stay, I'm going to actually keep control 2 is going to stay the same. So now I'm going to set my, so I'm going to keep this one, mass 2, at 720 the whole time. My other control is going to be my distance. So now I'm going to say the other control is meters. So now if I were to do a mass experiment, I'm just going to change mass 1. So I'm going to start that at maybe something smaller. So I'm going to start it at 190 kilograms. And then my force of gravity now is 1.01 E for that scientific notation, -6. And so I have a data point now that popped into my graph. So now what I might do is go ahead and change this again to something different, 330. And again, I type in, whoops, that didn't work, did it? Didn't know where I was at. 330. And now again, 1.76. I'm getting that number from right here. The letter E, -6. And again, we start to see another data point pop in there. So you need 10 data points on either mass or distance. And on that, what you will also want to do, and so your instructor might have said do one or the other. Your instructor may have said both. So just make sure you're following your instructor's directions on that part. All right, warriors, have fun graphing, and